The time T-minutes spent each day by students in Amy's school sending text messages may be modeled by a normal distribution. 30% of the students spend less than 10 minutes per day, and 35 spend more than 15 minutes per day. Find the mean and the standard deviation of T. All right, so we need to find the Z values, or you can use your calculator maybe. No, we have to use Z values. Tell me how I do this problem.
Well, you convert
T is the number of minutes spent, right?
Oh, you find that the inverse normal of that it's less than 30% and
Okay.
it's greater than 35%.
Okay, so we need to find those Z values. So we can do inverse normal of 0.3, right?
Mm-hmm.
And we should get negative 0.524. Are y'all with me?
Mm-hmm.
And then we can do, all right, so that was 30% of the students spend less than 10 minutes each day. All right, so that's going to be 30% is this way. Right?
Mm-hmm.
I asked you guys to draw these things, didn't I?
Yeah.
And I didn't see very many drawings. Maggie, you did. Andrew, did you?
Yeah.
Okay. All right, and then 35% spend more than 15 minutes each day. So, wait, 30% of the students spend less than 10 minutes each day. So this would correspond to the 10, right? All right, and 35% spend more than 15 minutes per day. So that's going to be that part of it. So how am I going to do that? 65%. I'm going to find inverse normal of 65%, right? And I get what? 0.3853. So that would be 0.35% over here. All right. So now I have my Z-scores. How do I find the mean and the standard deviation?
Use the x minus mu over sigma.
Yeah. Okay, so I'm going to have negative 0.524 is equal to 10 minus whatever mu is over the standard deviation. And I'm going to have, so that's negative 0.524 is equal, times standard deviation is equal to 10 minus mu. And then I have Z sub 2 is equal to x minus mu of the standard deviation, and that's 0.3853 is equal to x minus 15 minus mu over the standard deviation. So 0.3853 sigma is equal to 15 minus mu. And you need to solve that system, right? And you get mu is 12.9 and sigma is 5.50. Did anybody get that?
And what were the answers again?
Mu is, the mean is 12.9 and the standard deviation is 5.50.
I got the U part.
You did? Did you do it that way?
Sort of. Although I found the Z-scores and then I the ratio of each of those between, like from the mean, and I did that between 10 and 5, so kind of like that.
Okay. All right, well, that would seem like you would get the standard deviation versus the, okay, well, whatever. Everyone understand how to do that?
Yeah.
All right, B, or the number of text messages received by Amy during a fixed time interval may be modeled by a Poisson distribution with a mean of 6 messages per hour. Find the probability that Amy will receive exactly 8 messages between 16 and 1800 on a random day. So the X is the random variable number of text messages in 2 hours, right? Because 1600 to 1800. Why are we using military time? And the mean is going to be, it's 6 messages per hour, so the M is going to be 12. And you're going to do e to the negative 12 times 12 to the 8 over 8 factorial, you get 0.0655. All right? That was pretty straightforward. How did we do on that?
Good.
I feel like one of those teachers that has completely lost her students. Are you with me, or is this hard?
We're,
Half the kids.
I know it's half the kids, but like I'm not getting any.
so,
All right.
really probably here.
Given that Amy has received at least 10 messages between 1600 and 1800 on a random day, find the probability that she received 13 messages during that time. So the probability that she received 13, using my calculator, is 0.1055. Probability that she received greater than or equal to 10 is 0.758. So the probability that she received 13, given that she received greater than or equal to 10, is the probability that she received 13 over the probability that X is greater than or equal to 10, which is 1 minus the probability in the denominator that X is less than or equal to 9, which is 0.139. Now, that was worth 4 points, so here's what you had to do. You had to find the probability that X was 13. And what are you using as your random variable? What is X?
The number of text messages?
In how many hours?
2? Or
2 hours, right? Because we're still talking about between 16 and 1800. All right, you have 1 point for finding the probability that X is greater than or equal to 10, which is actually 1 minus the probability that X is less than or equal to 9, and using Poisson CDF. And then you have conditional probability, and that's how you get 0.139. All right, and D, during a 5-day week, find the probability that there are exactly 3 days when Amy receives no messages. So again, between 745 and 1800. Now we're into a binomial. Started out with the normal, went to a Poisson, and now we have a binomial. During a 5-day week, find the probability there are exactly 3 days when Amy receives no messages. All right, so I'm going to go 5, choose 3. No messages to the 3rd, and a message to the 2nd. Right?
Mhm.
Now what do we fill in for those things? From 1745 to 1800 is how many minutes?
15,
15 minutes.
which is
So a quarter.
0.25 hours.
0.25 hour, 1.5 hours, isn't it?
Yeah.
No?
No, 60 minutes.
15 minutes is 0.25 hours.
Yeah.
Okay.
Times 6 is
Times 6 is 1.5. So our M is 1.5. correct?
Mm-hmm.
All right. So what is the probability that if your M is 1.5 and your success is 0, what's the probability that she gets no messages on a given day? Do that in your calculator. Poisson PDF 1.5 comma 0.
One, two, two, three.
0.223. Right? Okay, now we can just go into a binomial PDF. Number of trials is 5. Probability of success is 0.223, comma, 3 successes.
0.067.
Yes. 0.067. I had to do that on my own. I mean, I didn't have it. I had just the answer there. All right. Questions? This is only part of what you do in AP statistics, in case you're wondering. Mhm. This is the easy part, I think.
That's the hard part.
Hard part is all that other probability stuff that you have to get a type 1 error, a type 2 error, and you have chi-square, and you have SIG-Ts and SIG-F. You have all these different tests that you have to run besides. Like, well, we haven't even gotten into the test. Have we done any tests, probability tests?
No.
Okay. All right, so we're moving on to the last couple sections, and I'm going to really combine these because they're relatively process-oriented. If I add up all the probabilities, what do I need to get?
1.
1. All right, so I'm on this page that says IB Mathematics Probability 2 Distributions. Y'all with me? This right here. Wait, have we already done this?
What did we use?
Yeah, I think we said discrete mathematics involves the study of functions.
No.
We haven't done this? Okay.
That's the one that.
All right. Discrete mathematics involves the study of functions with whole number domains, while areas of mathematics involve continuous functions with domains and ranges consisting of intervals of numbers. Okay? So the normal distribution is a continuous function, right? You can do an interval between negative 0.524 and 0.3853. What's the probability that I get any number between those two values? So an interval of numbers. Versus a binomial distribution is discrete. You can only have a whole number of trials. What's the probability that I get 3 successes? I can't go, what's the probability that I get 3.25 successes? You understand? Difference between continuous and discrete. Plus you have to be really quiet when you do discrete mathematics. Example 1, the sum from I equals 1 to 5 of x squared is a series with domain 1, 2, 3. And f of x equals x squared on the interval from 1 to 5 or 0 to 5 is a continuous function with all real numbers between 0 and 5. Definition 2. Capital X is called a discrete random variable, and we've been dealing with that, right? When I say probability that x is 3. It's a discrete random variable if it has the following properties. X takes on values x of 1, x of 2, x of 3, x of ... x of n. Each value of x is associated with a probability, piece of 1, piece of 2, piece of 3. Where the probability of x sub 1 occurring, written probability that capital X is x sub 1 is p sub 1. And 3, that the sum of all the probabilities is 1. Example 2. Capital P of x is equal to x is equal to 1/18 times 4 plus x. If x sub I is 1, 2, and 3, if my domain is 1, 2, and 3, and the sum is 1, or show that the sum is 1. Okay? Are you all with me? Okay. So I find the probability that the discrete random variable takes on the value of 1. So here's what I write. Probability of capital X is equal to 1. And I plug 1 into the formula, and I get 1/18 times 4 plus 1, which is 5/18. Probability that x is 2 is 1/18 times 4 plus 2, which is 6/18. And no, I'm not going to reduce that. Probability that x is 3 is 1/18 times 4 plus 3, which is 7/18. You add up all those probabilities, you get 5/18 plus 6/18 plus 7/18 is 18/18. So I've shown that the probabilities all add up to be 1. You cannot have a probability distribution function unless the sum of all the probabilities is 1. If I don't get 1, then that's not a probability distribution function. Example 3, the random variable x takes on the probability distribution shown in the table below. Find the value of c. Well, how do you find the value of c?
Adding it all up.
Add them all up and subtract to 1 or set them equal to 1, and you get c is equal to 1/12. Okay? All right, example 4, a bag contains 2 yellow marbles and 3 green marbles, which are randomly removed one at a time, without being replaced until a yellow marble is removed. Find the probability distribution of x, the number of marbles removed. All right, so there's how many marbles how many yellow marbles, well, how many marbles in the
5?
5. Okay. So there's 5 marbles, and what I'm going to do is remove one at a time without being replaced until I get a yellow marble. So the domain, if you will, of this success is that x is 0. Well, I have to eventually remove a yellow marble, right? So I'm going to say x could be 1. I pull 1 marble and it happens to be yellow, right? Or x could be 2, which would mean I pull a green marble and then I pull a yellow marble. Or x could be 3. Okay, let's write this out. Yellow. That's basically going to be yellow, right? Probability that x is 2 is going to be green and then yellow. Probability that x is 3 is going to be green, green, yellow. Probability that x is 4 is green, 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 yellow. Can I go any further than that? No. All right, so those are possible outcomes. What is the probability that I get a yellow on the first try? 2 out of 5, right? Because I have 2 and I have 5 marbles in all. What's the probability that I get green on the first try? 3 out of 5, and then I get yellow 2 out of 4. So that's 6 20s, 3/10, right? Okay, green, green,